Today we'll be talking about transformations. Our objectives: we will be able to solve problems involving symmetry and transformation. We will be able to determine whether a figure has been translated, reflected, rotated, or dilated using coordinate methods. So, a transformation occurs when a figure changes or moves. The pre-image is the figure before the change. It should help that the prefix pre means before. The image is the figure after the change. And an isometry is a figure that does not change shape or size. So the first type of transformation we're going to talk about is a line reflection. A line reflection is the mirror image of a figure over a line. That line is called a line of reflection. So if we're looking at triangle ABC, that's our pre-image. When we reflect it on the other side, it's like we're looking on the other side of a mirror. So this line of reflection here is our mirror line, our line of reflection. So however far away A is from this line, A's image, or A prime, mark them with little apostrophes, called A prime, or B prime and C prime, are the same distance away from that line as the original. It's just on the other side. So if we want to reflect the quadrilateral over the line y equals x, well, y equals x means that y and x are always equal to each other on that line. So 0, 0, 1, 1, 2, 2, 3, 3, all the way on, as well as into the negatives. That's our line, y equals x. What it means when we reflect over the line y equals x, it means we're going to switch x and y. Because it's a diagonal, it's not as easy to count just across when it's a vertical or horizontal line. So let's look at this top of our quadrilateral. That's at the point 4, 0. So to reflect it over the line y equals x, we would go to 0, 4. This coordinate is at 6, -3. So we're just going to switch them, and we're going to go -3, 6. This is at 4, -5. So we're going to go -5, 4. And our last one's at 2, -4. So we're going to go -4 and 2. Now we can connect them to draw our quadrilateral. Our shape's the same, and if we folded over the line, they would line up with each other. Our next type of transformation is a translation. A translation is a slide that moves every point of a figure the same distance in the same direction. So if you look at this picture, the way ABC looks didn't change. It just looks like we took it just slid it down here. Nothing else changed about it. So the vertices of triangle ABC are 1, 1, 3, 4, and 5, 0. Graph the preimage and the image by translating left 3 and up 2 units. Write the coordinates of A prime, B prime, and C prime. So start by drawing our first triangle. 1, 1 is A, 3, 4 is B, and 5, 0 is C. So there's my pre-image. So now I'm going to take each of these points and I'm going to go left 3 and up 2. So I'm going to start with A, I'm right here. I'm going to go left 3 and up 2. And that will be A prime. I'm going to take my B point. I'm going to go left 3, up 2, there's B prime. Take my C point, go left 3, up 2, there's C prime. So let's write the coordinates. A prime is at -2, 3. B prime is at 0, 6. And C prime is at 2, 2. If you notice, left 3 is like negative 3. All the x coordinates decreased by 3. And then we went up 2, which is positive 2. All of our y coordinates increased by 2. Our third type of transformation is a rotation. A rotation turns a figure a given number of degrees around a point. And this table here, if you remember it, can help shorten the amount of work you need to do to rotate these. So if our original point, our pre-image, is the coordinate AB, we rotate 90, we're going to switch them and make what was our y coordinate the opposite sign. 180 degree rotation, x and y are going to stay in the same place, but we're going to switch the signs of them. And 270 degrees counterclockwise is we're going to switch them and make the old x coordinate negative. So let's look at our pre-image here, this triangle. It has the coordinates 2, 2, 4, 6, and 5, 1. We're going 90 degrees counterclockwise. So 90 degrees counterclockwise. So I'm going to take my coordinates, I'm going to switch them, so 6, 4, and then the first coordinate gets the opposite sign, so negative 6, 4. The coordinate 5, 1. Switch the order, make the first one negative, negative 1, 5, and then 2, 2, switch the order, and make the first one negative, and negative 2, 2. So it's like we tied a string to the corner point, and we took it and we turned the image 90 degrees. In this one, we are going to rotate 270 degrees counterclockwise. So we're going to follow this pattern. Our coordinates are negative 1, 2, negative 5, 1, and negative 1, 5. So our new points, after we rotate them, we're going to switch the order, but we're going to make the second coordinate negative. So switch 2 and negative 1. Now the negative 1 is already negative, but we have a negative a up here. That means we have to switch the sign, so it's going to become negative negative, which is positive 1. Switch the order of 1, negative 5. Switch the sign of the second coordinate. 5, negative 1, switch this on. So now we can plot them. 2, 1, 1, 5, and 5, 1. That's what would happen if we took our triangle and turned it 270 degrees counterclockwise. So we're going to spin it all the way around to here. Alright, what if we want to combine two transformations? Triangle FMA is reflected about the y-axis and then is translated up 9 units. So we're going to reflect over the y, and then we're going to translate it up 9. What are the coordinates of point M after the translation? So the nice thing about this is we don't have to reflect and translate all of the coordinates. We just have to reflect and translate M. So right here, if we reflect over the y-axis, remember this is our y-axis, M is 1, 2, 3, 4, 5 spaces away, so we're going to go 5 spaces on the other side. 1, 2, 3, 4, 5, and then from there we need to go up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's where M prime would be. And where is that coordinate? That's it. Negative 1, 2, 3, 4, 5, 1, 2, 3, 4. So negative 5, 4. In your summary, write about why you might need to know how to reflect, translate, or rotate something in real life. See you in class.